Hello. In this lecture I am going to discuss how the nature of the electrolyte affect the product of electrolysis in a particular electrolytic process. Okay. Here nature of the electrolyte, what I mean by nature of the electrolyte is that whether you take the electrolyte in the molten state or in the dissolved state. Okay. So in electrolysis we can take the electrolyte in molten state or you can take the electrolyte in the dissolved state, right? In the molten state only the ions from the electrolyte is available for oxidation or reduction. Okay, so here you need not worry about any other ions, right? Only, I'll write like here, only the ions from electrolyte, okay, only the ions from electrolyte take part in chemical reaction or in electrolytic reaction. Only the ions from the electrolyte. Whereas when you take a dissolved electrolyte in the dissolved state, what is meant by that? If you dissolve some electrolyte in water or in alcohol, right? We have different solvents. So if you dissolve the electrolyte in some solvent, if the solvent is capable to furnish ions, then those ions may also undergo oxidation or reduction at the electrodes. For example, if you take aqueous, or if you dissolve sodium chloride in water, so we'll get aqueous sodium chloride, right? In aqueous sodium chloride we have sodium ion in aqueous medium, we have chloride ion in aqueous medium. Apart from these ions, these two ions comes from the electrolyte. Apart from these two ions, okay, the self ionization of water produces ions like H plus and OH minus, whereas these ions are not available in the molten state, right? In molten state only the ions from the electrolyte are available for reaction, whereas in the dissolved state, okay, the ions from the self ionization of water, right, may also participate in the reaction. Okay, so whenever electrolyte is given in the dissolved state, then you should be little careful, okay, in predicting the product of electrolysis, right? I'll explain this by using solvent as water. Okay, say for example, if you take water as solvent, right, then apart from the main ions, that is ions from the electrolyte, the self ionization of water produces ions like H plus in aqueous medium and OH minus in aqueous medium. Okay, these two ions are also take part in the electrolytic reaction. These ions are actually comes from the self ionization of water. Now these ions, okay, can undergo oxidation and reduction at the respective electrodes. For example, H plus ions, right, approaches the cathode and undergo reduction. What is the reduction reaction? The reduction reaction is this. So at cathode, the H plus ions produced from water, okay, approaches the cathode and gains electron. Okay, actually 2 H plus ions gains 2 electron and get reduced to hydrogen gas. Okay, then actually this H plus comes from water, therefore I am going to consider the ionization of water here. So H2O liquid ionizes to give H plus ion in aqueous medium and OH minus ion in aqueous medium. Right? Here we require 2H plus. Okay, so to get 2H plus here, I'm going to multiply throughout the reaction by 2. Okay, now if I sum up these two, right, H plus cancels, so you will get a reaction like this. H2O liquid gains 2 electron and gives you hydrogen gas plus 2 OH minus ion in the aqueous medium. Right? See, this is not the actual reaction occurring at the electrode. The actual reaction occurring at the electrode is this, but the H plus comes from water. Okay, and there is an equilibrium between this. I am not going to discuss that. Okay, so this reaction must be included here. If you include that and if you add the two reactions, then this is the reaction that we have to consider. And this is actually the reduction reaction. For this reduction reaction, the reduction potential is, so reduction potential for H2O becoming H2 is minus 0.83 volt. This is the reduction potential for water. Okay, so whenever you take water as solvent, right, then water undergoes self-ionization, produce H plus and OH minus. This H plus ion approaches the cathode and there is a possibility that H plus can undergo reduction. If H plus undergo reduction, then the overall reaction for H plus reduction is this. Okay, and the reduction potential for this reaction is minus 0.83 volt. Similarly, the OH minus ion, okay, being a negative ion, it will approach the anode and undergoes oxidation. Okay, let me write to the next page. So, what happens at anode? At anode, this OH minus ion from water, okay, it will undergo oxidation. How? First, it will lose one H plus. I'll write like this so that you can easily understand this, and you will get O2 minus ion. Just for understanding purpose, I am writing like this. First, OH minus ionizes to give H plus and O2 minus ion. This O2 minus ion actually undergoing oxidation. Right? O2 minus ion loses, I'll take 2 O2 minus ion, loses 4 electron and become oxygen molecule, and it comes out as oxygen gas. Okay, so to get 2 O2 minus, we have to multiply the first reaction by 2 throughout the reaction by 2. Right? Then this OH minus comes from ionization of water, self-ionization of water. So self-ionization of water, I'll include here. H2O liquid ionizes to give H plus in aqueous medium and OH minus ion in aqueous medium. Right? And here we have 2 OH minus. So what I'm going to do, I'm going to multiply throughout this reaction by 2. 2, 2, 2. Now I'm going to sum up these to get the overall reaction. So what's the overall reaction? You can cancel same species if it exists in the left hand side and right hand side. Okay, you can cancel them. Then 2 O2 minus ion, 2 O2 minus ion get cancelled. So what is the final reaction? The final reaction is in the left hand side we have water molecule, H2O liquid. In the right hand side, here we have 2H plus, here we have 2H plus, so there are 4H plus ion in the right hand side, plus O2 molecule, which comes out as gas, plus 4 electron. So this is the oxidation reaction that occur at the, this is one possible oxidation reaction that occur at the anode. Right? So whenever solvent undergoes self-ionization, and if those ions, right, are capable to participate in the oxidation or reduction reaction at the electrode, then we have to concentrate on these reactions. And what is the oxidation potential? See here, H2O becoming O2. For H2O becoming O2, for this reaction, the oxidation potential value is minus 1.23 volt. Okay, so these two reactions, that is there are possible reduction reaction at the cathode and the possible reduction at oxidation reaction at the anode. These two reactions must also be considered, okay, along with the main reactions, that is the ions that are produced from electrolyte. They may undergo oxidation reduction, so along with those ions you have to consider these two. Okay, yeah. So this is very important, because whenever you take electrolyte in the dissolved state, the solvent molecule, right, must also participate in the electrolytic reaction process, right? Now the next one is that regarding over voltage. So I'll tell you what is the concept of over voltage and why it is required here. Over voltage or over potential. Over voltage or over potential. What is meant by that? See, whenever gas evolution takes place during the reduction reaction or oxidation reaction at the electrodes, okay, along with what happens is that these gases that is produced at the beginning, they form a layer on the surface of the electrode, right? And this initially formed layer will prevent the further oxidation or the further reduction reaction of the electrode. Okay, so to continue the oxidation or to continue the reduction, you need to give a little more potential, which we call as over potential for the respective electrode. Okay, so what is over potential? It is the additional potential required. It is the little excess potential required to continue the reduction or oxidation reaction occurs at the electrode whenever gas evolution takes place. Right? Very specifically hydrogen gas or oxygen gas. Okay, if gas evolution occurs at the electrode, then we require little excess potential to continue the reduction reaction or oxidation reaction. This excess potential, okay, is what we call as over potential or over voltage. This excess potential, right, is what we call as over potential or over voltage. Over potential or over voltage. Okay, now for this over potential depends on the electrode that we use, and it also depends on the gas that is evolved. Okay, let me give over voltage for few electrodes, and depending upon the gas, okay, how the over voltage changes, right? So this is actually a very important one. Most of the time we may not consider this, but this is very, very important. Let me give the values for over voltage at different electrodes. So the over voltage for different electrodes are available. Okay, I'm not going to give all the electrode, but I'll give few electrodes. Hydrogen gas over voltage, I'll write like this: hydrogen over voltage, oxygen over voltage. Okay, for platinized platinum electrode, right? Hydrogen over voltage is 0. For hydrogen gas, when hydrogen gas is evolving at the platinum electrode, you need not worry about the over voltage because over voltage is 0. Whereas for oxygen evolution, the over voltage is 0.25. You have to supply 0.25 extra voltage to continue the reaction. Okay, see why I'm telling this, because in when solvent undergoes oxidation, very specifically in the case of water, when water undergoes oxidation, it produces oxygen gas, right? Suppose if you use platinum as electrode, then this oxygen gas adsorb on the surface of the electrode at the beginning. It will prevent the further oxidation of this reaction, right? So if you supply the extra 0.25 voltage, right, what will happen? The reaction again progress. Okay, the reaction continues. Therefore, including the over voltage, this will become, I have to add the minus 0.25 volt here. So if we add, then I'll get minus 1.48 volt. What is this? This is the voltage actually required. Okay, this is including over voltage, right? So for platinum electrode, hydrogen over voltage is 0, whereas for oxygen evolution, there is some voltage required called the value is 0.25 volt. Similarly, we have a different over voltage for different electrodes, right? For iron, if we use iron as the electrode, then hydrogen over voltage is 0.08, right? Oxygen over voltage is 0.24. And if you use nickel as electrode, for nickel the over voltage, hydrogen over voltage is 0.22 and oxygen over voltage is 0.06, right? For mercury, right, hydrogen over voltage is highest, 0.8. Okay, hydrogen over voltage is highest for mercury. For oxygen over voltage is 0 actually, right? Yeah, so keep all these things in mind. These are all very, very important whenever you we need to predict the product of electrolysis. You must consider all these quantities. Okay, so keep this in mind. When water molecule, right, when you use aqueous electrolyte, then water has the chance to undergo oxidation. When water undergoes oxidation, oxygen gas get evolved, correct? If this oxygen gas evolves, right, suppose if you use platinum electrode, then you require some over voltage. It's called oxygen over voltage. Oxygen over voltage for platinum electrode is 0.25, right? But the actual potential for this reaction, oxidation potential, is minus 1.23. Since oxygen gas adsorb on the surface of platinum electrode and requires extra voltage, so you need this much extra voltage to continue the reaction. Okay, this is called the over voltage, right? And these are all the few examples for hydrogen over voltage and oxygen over voltage. Okay, yeah, so keep all these things in mind. In the next class, what I'm going to do, how to use the SRP values and SOP values to identify the product. Okay, what I'm trying to say is that, see, at cathode, we know very well, at cathode, cations approach the cathode and undergo reduction, right? So whatever cations present in the solution, okay, that will undergo reduction. Cations undergo reduction. Okay, now suppose if we have two or more cations, Suppose I have a cation A plus and cation B plus, like that, right? Even solvent molecule may also take part in the reduction reaction. Suppose if I use water as solvent, then water should also be considered here. Now among the three, which one will undergo reduction first? To identify that, you need to consider SRP values. What is SRP? SRP means standard reduction potential. Okay, so for reduction of A plus to A, right, this not symbol indicates standard. E means potential, so it is called standard reduction potential for A plus ion. And we need to consider standard reduction potential for B plus ion, and we need to consider standard reduction potential for H2O becoming hydrogen. H2O, when H2O becomes H2, it is called reduction reaction, right? Compare the values. Suppose if this value is high among the three, if this value is the highest, then A plus ion will undergo reduction first, right? Once all A plus ion get reduced, then if you increase the voltage further from battery, then the second ion will undergo oxidation. Reduction. Okay, so for cathode, you have to focus on SRP values. Similarly, at anode, anions approaches anode, right, and undergo what is called oxidation. Anions approach anode and undergoes oxidation, right? Suppose if we have a few anions like A minus, B minus, and water molecule, see, self ionization of water produce OH minus. That OH minus will undergo oxidation, but while writing the equation, we won't consider OH minus, we'll consider only water. Okay, we have discussed already in this lecture. Now for oxidation reaction, you have to consider SOP values. What is SOP? Standard oxidation potential. Okay, so standard oxidation potential A minus becoming A, standard oxidation potential for B minus becoming B, then standard oxidation potential for H2O becoming oxygen, right? Compare the values. Suppose for the second species the value is highest, right? SOP value is highest for the second species. Then among the three, the B minus ion will undergo oxidation first. Okay, so whenever two or more species are available to undergo oxidation or to undergo reduction, then you have to consider this SOP or SRP value depending upon the electrode, right? Yeah, I stop here. We'll continue this lecture in the next class. Thank you.